This session is for OCR FP2. We're looking at the topic of integration and we're doing question 8 from June 2011. So if we start just by reading through the question. So we're asked to use the substitution x equals cos squared u to find the integral of root x over x minus 1, giving our answer in the form f of x plus log g of x. We're then asked to calculate the exact area of the region between the curve y equals root x over x minus 1, the x-axis, and the lines x equals 1 and x equals 4, which we can see in the diagram. And then in part 3, what can you deduce about the volume of solid of revolution obtained when the region defined in part 2 is rotated completely about the x-axis? Justify your answer. So it's a question worth 11 marks. So let's have a look at part 1 first of all. So we're going to be asked to we're asked to use this substitution x equals cos squared u. So let's just start by doing a little bit of work over here. So that means we will need to work out what dx is. So dx by du will be 2 cos u sin u. And if we just call the integral I, then effectively we've got root x on the top line, which is cos u, and we've got root x minus 1, which will be the square root of cos squared minus 1, which is just sin u. And then we have to multiply by dx, so that will be 2 cos u sin u, and now we're integrating with respect to u. So we can divide through top and bottom line by sin u, and we end up now having to integrate 2 cos squared u. So at this stage we need to remember the trick, and that we have to write and use the identity. Cos 2u will be 2 cos squared u minus 1. So in our particular case we're going to be able to write that as cos 2u plus 1. So it's a little bit like we did in trigonometry with the using the double angle formula. And now of course we have got it in the form we can integrate, so that's going to be a half sin 2u plus u plus a constant. And now we have we only know the relationship between x and cos u, so we'll write this now as sin u cos u. So just notice that the 2 and the half will sort themselves out there, and then we have a u plus c. And now what we will need to remember, of course, is that we know that root x is equal to cos u. So that means that u is cos to the minus 1 of root x, or x to the half perhaps, whichever you prefer, whichever you find easier. So we have that information, so we can substitute back in now. So sin u is going to be x to the half, cos u is going to be x minus 1 to the half, and then u, if we use, and again you can check this from your formula books, but cos to the minus 1 of x to the half will be log of x to the half plus x minus 1 to the power of a half plus c. So we have now given our answer in the form of f of x plus log of g of x. So there were 7 marks for that question, so if we just have a look at how those marks are actually given. So you got a B mark here for just writing down dx by du. You got a method mark here for making the substitution, and an accuracy mark if you got as far as this, 2 cosh squared u, the integral. A method mark for seeing that you had to rearrange it in the form cosh 2u plus 1. An accuracy mark here for integrating, and then a method mark and for substituting back in for u, and an accuracy mark if you got it all correct. So 7 marks in total. So let's now have a look at the second part and see what we have to do here. So it says, hence calculate the exact area of the region between the curve, the x-axis, and the line x equals 1 and x equals 4. So we want that area is then going to be the equal to the integral between 1 and 4 of x over root x minus 1. Sorry, it's the square root of the whole thing, isn't it? Just take that away. So it's x minus 1, and it's the square root of all of that. So that's what we had. And we found that the answer to that was x to the half upon x minus 1 to the power of a half. That was our f of x, and then we had our log function, which was log of x to the half plus x minus 1 to the power of a half. And we're going to now evaluate that between 1 and 4. So just substituting in, so we'll have 2 times 4 minus 1, so that's root 3, and then we'll have log, so this is the first bit when x is equal to 4, so we'll have log of 2 plus root 3. And then from that we're subtracting. When x equals 1, this term will disappear, so we'll get 0. And here we'll have log of, so it's going to be log of 1. And log of 1, of course, is equal to 0. So what we end up with is 2 root 3 plus log of 2 plus root 3. So there was just a mark for working that through. So just 1 mark. And then the last part of the question, it says in part 3, what can you say about the volume of the solid of revolution? So remember that we're finding pi times the integral of y squared dx, which in this particular case is going to be pi times the integral of x over x minus 1 dx. Now, I'm not too sure, there are different ways in which you could do it, but you can think of x over x minus 1 as x minus 1 plus 1. So we can sort of rearrange the numerator to write it like that. So we end up with a 1 plus 1 over x. So what we end up with is we're integrating pi times the integral of 1 plus 1 over x minus 1. And we're actually integrating all of that. And again, we're integrating between 1 and 4. So of course, if we do that, then we'll get, I've got me pi again, so we'll get an x here, and when we integrate 1 over x minus 1, we're going to get log of x minus 1. Now when we substitute that in, we're going to be alright when we substitute in the 4 plus log 3, but when we substitute in x equals 1, we're going to get a log of nothing, which of course is undefined. So the volume is going to tend to infinity. So that's the important thing about that question. And if we just look at the marks for the question, then you got a method mark for seeing that we had to find that integral. You had an accuracy mark here, and then you had a statement mark then for seeing that because this was undefined, our volume is going to tend to infinity. So, as I say, 3 marks for that. There was 7 marks for the first part and 1 mark, so 11 marks in total for the question. So don't forget that if you want to watch further revision videos, then you can do that by going to the Further Maths Support Programme website and following the link.